Okay, here we go. So we talked in class that I had one more example that I wanted to get done but ran out of time. And these are the more important examples to know how to do. So I thought that it was important for me to be able to show it to you. So that's why I'm doing this video here. And this is the radius function we're given, and we want to find curvature, and we want to find tangential and normal components of acceleration. Remember, that's our notation for the tangential component of acceleration. This is our notation for the normal component of acceleration. If you remember, we have a million different formulas for curvature when it comes to having three components. It's neither of our special cases, so we have to look into the other different formulas we have for curvature. Remember, there's a whole bunch. There's that big one that we decided may not be very useful that we fixed in class, and there are some other ones, but I think the one that we're going to find most useful here, especially since we have to find tangential component of acceleration and normal component of acceleration, is we're going to end up using this one right here, where k equal to the magnitude of v cross a over the magnitude of v cubed. And this is also the speed. Remember, the magnitude of v is also the speed. There's also ds dt, which is the change in arc length with respect to time. You have all those different type names for this same thing, which is the magnitude of v. And the reason we use this one is because the normal component is just going to be, because remember, an we're going to use is equal to 3 cross a over v. Right, so since these are so similar, while we're calculating one, it won't be very hard to calculate the other one. So first, to get v and a, so we can cross them, we have to take v and a. And remember that v of t is equal to r prime of t, which is equal to 2I plus 2t j plus 1 over t k. The magnitude of v is going to be equal to the square root of 4 plus 4t squared 1 over t squared. Alright, so I squared all the components. I took the square root of the whole thing. Acceleration of t, we're going to have is equal to v prime. So we're going to take, the I goes away, so we just have 2j minus 1 over t squared k hat. Okay? So here we go. If we want to cross these, we have to set up our table. Set up our table, so I, j, k, 2 t 1 over t, and then 0, 2 minus 1 over t squared. Okay, so we cross it. Remember, we're taking determinants, so we're just going to get v cross a is going to be equal to, well, this is minus 2 over t minus 2 over t. It's minus 4 over t. I, then we get minus, because it's always minus whatever it is when you cover up the j, and you get minus 2 over t squared, so minus 2 over t squared, that's going to be plus 2 over t squared k. And the last one is just going to be plus 4. Okay, so then we're really concerned about the magnitude of v cross A. So the magnitude v cross A is going to be equal to the square root of, square them all up, 16 over t squared plus 4 over t to the 4th plus 16. Alright, so now we can have our, we can find our equation for curvature. So that's k is going to be equal to, let me make sure I'm in the frame still. Yep, I'm at the very bottom. So k is going to be equal to our big square root, so 16 over t squared plus 4 over t to the 4th. Did I write t to the 4th? Let's look at what k was. Yeah, 4 over t to the 4th plus 16 divided by b cubed, so that's, here we go, that's 4 plus 4t squared plus 1 over t squared. Now it was 3 halves, right, because it's square root cubed. And then an, which is the normal component of acceleration, is just going to be the same thing, except the denominator is not going to be cubed. Right. So we write the same thing. 16 over t squared plus 4 over t to the 4th plus 16, sorry, I'm running out of space, over, I guess we can move it up a little bit so we can make sure we're all in the screen, all over square root of 4 plus 4t squared 1 over t squared, so magnitude of v. Alright, lastly, all we need to do is find our all we need to find is our tangential component of A. So let's use this formula. A tangential is equal to V dot A over magnitude of B. What's V dot A? So we have V here, A here. So V dot A is going to be 2 times 0 is 0 plus 4, or 2t times 2, 4t plus, and then now we have minus 1 over t cubed, minus 1 over t cubed, and that's over this magnitude of v that we'll write down again for our final answer, 4 plus 4t squared plus 1 over t squared. Okay, so now we have our normal component of acceleration, our curvature, which looks a lot like the normal component of acceleration, but you're dividing by the speed cubed versus just dividing through by the speed. And then our tangential, which comes from a different formula, one that we wrote on the board on Thursday. So this is one of those things where you just kind of have to go with the curvature equation and pick it. It wasn't pretty at all, but it's really easy to write down. It's kind of difficult to calculate because you got to take a cross product here, take the magnitude of that cross product here, but everything's straightforward. And these are the more like what kind of problems you're going to get, and you're oftentimes going to get a curve that's going to be defined with 3 components, and you're going to want to know everything about it. Curvature at any given time t, an acceleration, or tangential component of acceleration at any given time t, or a normal component of acceleration at any given time t, and here we have it. And that's it. This is kind of the end of that section 14.5 that we had to get to. Thanks for watching the video.